Hi, I'm Keith Anderson with the University of Montana. Today we're going to talk about correlation and causation, what you need to know, and how to differentiate between these two concepts. So what is correlation? Correlation is simply a relationship or an association between two variables. Correlation can be positive, it can be negative, or there can be no correlation. Correlation coefficients range from 1.0, which is a perfect positive correlation, to negative 1.0, which is a perfect negative correlation. So some examples of correlation could be height and weight. The taller people are, the more they tend to weigh. We could look at engine size and miles per gallon, and this would be a negative correlation. The bigger your engine, probably the lower your miles per gallon. And then no correlation, maybe something like being left-handed and your karaoke ability. I don't know if there's any relationship there. I don't anticipate there would be. Causation is related to correlation, so for there to be causation, two variables have to be related. But with causation, a change in the value of one variable will cause a change in the value of another variable. So examples could be something like weightlifting and strength. The more you lift weights, probably the stronger you become. Caloric intake and weight. The more calories you eat, the more you weigh, or the less calories you eat, the less you weigh. Or something like studying time and your performance on an exam. The more you study, logically, the better you'll perform on an exam. We have to be careful with correlation and causation, and remember that correlation does not imply causation. So some examples could be eating ice cream and drowning. We know that the rates of eating ice cream and the rates of drowning tend to parallel each other, and this happens in the summertime. So an ill-informed researcher might make the assumption that eating ice cream causes drowning, when in reality, it's the fact that both of these activities are happening in the summer, more people are swimming, and rates of drowning are higher. We could also look at something like automobile accidents and Thanksgiving. Automobile accidents tend to spike during Thanksgiving, so again, the ill-informed researcher might think that Thanksgiving causes accidents, when in reality, more people are on the road traveling to visit people for Thanksgiving, and there's more accidents. And the final example is drawn from an actual research study where they found that children who slept with night lights later on developed poor eyesight. So they said that was the cause. When in reality, it was parents who had poor eyesight tended to have night lights in their children's rooms so they could check on them and not fall down. And the kids later on just inherited that genetic trait of poor eyesight. So we have to be really careful with correlation, and remember that correlation does not imply causation. So how do we establish causation? There has to be a logical association. There has to be an association between the two variables, and the association has to be logical. So again, ice cream and drowning, there's really no logical link there. Timing and order, the cause must occur before the outcome. So caloric intake and weight. There has to be an order to things. And then we have to eliminate other explanations. We have to investigate whether there are other factors that might account for the change. In research, we do this by controlling for variables and including these other variables in our experiments and in our research. So that's correlation and causation. It's fairly simple, but oftentimes confused, so be careful with this. If you have any more questions, you can always contact us at the University of Montana. Thank you.